In this video, we are going to wrap up our work on quadratics by talking about the discriminant. We'll first talk about what it is, and then we'll talk about how it works. So first of all, what it is. The discriminant is the part that's underneath the square root in the quadratic formula. You remember when we did the quadratic formula, the first thing we had to simplify was the part that was underneath the square root. So what we were actually doing was finding the discriminant value at that time. Okay, notice that the square root is not part of the discriminant. The discriminant is just this green part. It's the part that's inside the square root. It is not the square root itself. Okay, so let's see what the discriminant value does. When I type this part into my calculator or I work it out using order of operations, if I get a number that is greater than 0, that is to say I get a number that is positive. Okay, well, what does that mean for my quadratic? Okay, so let's look up here at the quadratic formula. If this number that's inside the square root is positive, what kind of answers am I going to get? Well, I'm going to get real numbers because real numbers, the square root of a positive gives me a real number. And you'll notice I have plus that real number and also minus that real number, which is going to give me two real roots. And they're going to be different from one another. Now, they may not be perfect square numbers. They may be irrational roots, but they are both going to be real because the number inside the square root is positive, and the square root of a positive is a real number. Okay, so now let's think about this for a second. This gets kind of confusing for people sometimes. The fact that this discriminant value is positive doesn't have anything to do with whether the quadratic itself opens up or opens down. You remember when we put a quadratic in standard form, the a value, if it is positive, the graph opens up, and if it's negative, the graph opens down. But that doesn't have anything to do with this discriminant value. So my graph might go this way. My graph might, in fact, open up. But what the discriminant tells me is that it's going to cross the x-axis 2 times, right? I have 2 real roots. If my roots are real, that means I should see x-intercepts. So I'm going to have 2 x-intercepts. It's also just as likely that my graph opens down. But again, I have 2 x-intercepts. I have 2 real roots. So the fact that this number is positive doesn't have anything to do with whether or not my graph opens up or down. What it tells me is that I have 2 x-intercepts. Okay, let's move to the next. When the discriminant value equals 0. Okay, so let's look what we have right here. This green part, when we type it in our calculator and we do order of operations, we're going to get 0. And I remember that the square root of 0 is 0. So this is going to be the opposite of b plus 0 or the opposite of b minus 0. And remember we did one of these the other day. Adding and subtracting 0 doesn't change the value of the number. So I am going to get a real root, right? Because the square root of 0 is 0. It's not imaginary. But what I'm going to see is one distinct real root. I'm going to use the word distinct there because I do actually have 2 roots. Remember the one we did the other day was negative 1/3 and negative 1/3. It just so happens that my root repeats itself. I always have 2 roots. It's just that my 2 roots may not be different from one another. So I have one distinct real root. I have one that you can tell the difference between because the 2 that I have are identical. Okay, so what does that mean for the graph? Well, if I have one distinct real root, that means I should only see one x-intercept. So maybe the graph is going to look like this. You can see it sitting right there on the x-axis. This one happens to be sitting on the origin, but it doesn't have to. The important thing is that it's sitting on the x-axis and it touches the x-axis one time. It might just as easily be sitting somewhere else on the x-axis, but again, it's only touching the x-axis in that one point. It's actually going to come down and then it's going to bounce off like a trampoline, right? It's going to come down and hit it and bounce off. So when I have a 0, I have one distinct real root because my 2 roots are the same as one another. Okay, well, what if it's less than 0? That is to say that the number I get when I simplify the discriminant is a negative number. Okay, so look what we have here. So I have the square root of a negative. Well, when I have the square root of a negative number, what type of answer do I get? It's imaginary. So I have my real number right here, negative b, plus an imaginary number. Well, when I have a real and an imaginary put together, that gives me a complex. So I'm going to have two complex roots, again, because I have the plus and the minus. I'm going to get two separate ones, but I'm going to have 0 real roots. Okay, we did one like this the other day too. Do you remember what happens when we have two complex roots? Well, because there are no real roots, it doesn't cross the x-axis at all. So here's the x-axis, and you can see my parabola right here, never crossing the x-axis. It could also be going down, right? It can be like this, and it doesn't cross the x-axis because it stays below it. So regardless of whether it is above or below, the important thing is when the discriminant value is 0, I have two complex roots, which I should not be able to graph on my real axes. Okay, so let's try this one. We're going to use the quadratic formula and the discriminant so that we can figure out not only the type of roots, but then we're going to go back and show that those actually are the roots that we get. Okay, so the quadratic formula. Let's practice that. Negative b plus or minus the square root b squared minus 4ac all divided by 2a. And remember, I told those of you guys who are planning on going forward into a college algebra or a pre-cal type class, you will need to have this memorized before you get there. All right, so let's identify what is A, what is B, and what is C in this particular quadratic. All right, we've been practicing this with factoring and with the quadratic formula. So A is the coefficient on the x squared, which in this case is the understood 1. B is the coefficient on x, the negative 5, and C is the constant with no x. Notice that all of these are just plain numbers. There are no variables. Okay, so now I'm going to substitute in. So the opposite of B, well, B is negative 5, so the opposite of negative 5 is positive 5. All right, now I'm going to change colors for my discriminant here, and I'm going to get b squared. I'm going to remember to put that negative number in parentheses so that my calculator will give me the right answer. All divided by 2 times 1. Okay, so let's simplify the discriminant value first and figure out what that tells us. Okay, I went ahead and typed that discriminant value into my calculator, and the part underneath the square root is equal to 81. Okay, so now let's think about what that means. Go back and look at your notes. 81 is a positive number, so what does that tell me about my roots? It tells me I should have two real roots. Okay, so let's see what's going to happen. So I've got 5 plus and minus. All right, what is the square root of 81? Well, 81 is a perfect square number. Square root of 81 is 9. 2 times 1 is 2 down there in the denominator. Okay, and again, y'all be really careful. Some of y'all are putting an extra square root on here. The square root of 81 is just plain 9. There's no square root anymore. Okay, so my discriminant tells me that I should have two real roots. So let's split this up and figure out what they're going to be. 5 plus 9 divided by 2 will be the first one. 5 minus 9 divided by 2 will be the second one. Okay, so let's simplify those. 5 plus 9 is 14. 14 divided by 2 is 7. 5 minus 9 is negative 4. Negative 4 divided by 2 is negative 2. So what this tells me is my two solutions, which in this case are real roots, are also going to be the x-intercepts, or the zeros, of this particular function. And I asked Desmos to graph it for me, and here's that parabola, and you can see that it crosses the x-axis at negative 2 and positive 7, which are the two numbers that we found. So this one does have two x-intercepts, or two real roots. The two solutions to this equation are those two values, negative 2 and positive 7. Okay, let's do this one. So the way it was originally written, it worked out to be almost exactly like the last one. So let's put a 3 here in front of the x squared so that we can practice something different. Okay, I'm going to write the quadratic formula up here again. Y'all practice with me. Negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Okay, so now let's figure out what a, b, and c are going to be. A is going to be 3, the coefficient on the x squared. B is going to be 10, the coefficient on the x, and C is going to be 22. Okay, let's substitute into our formula. Opposite of B, opposite of 10 is negative 10, minus the square root. Okay, I can choose to put this 10 in parentheses or not put it in parentheses. It doesn't matter because it's positive. You only have to have the parentheses when it's negative. 4 times A times C, all divided by 2A. Okay, so the first question I'm going to ask you, I wrote it all in the same color this time. Which part of this is the discriminant? It's this part, the part that's underneath the square root, the part that we're going to simplify first. Okay, so you have the option of either typing that into your calculator or working it out using order of operations. Either one is good. Either way you do this, you're going to end up here with negative 164. Okay, so look back at your notes. When my discriminant value is negative, what does that tell me? It tells me I'm going to have two complex roots, so I will have no x-intercept. Now look at the graph of this one. It should not cross my x-axis at all. Okay, let's finish out the simplification here. Let's practice with the quadratic formula. All right, what do I need to do with that 164? Let's make a factor tree. All right, well, I know 164 is divisible by 4. 4 goes into 164 41 times. 4 is 2 and 2. 41 is prime. So if I cross out my composites and I circle my pairs, all right, now look back. Remember that we have a negative 164 right here. So what should go outside of my square root? Outside, I'm going to have the 2 that I circled, but also an I because 164 is negative, and left on the inside will be 41. Okay, now look at all the numbers on the outside, 10, 2, and 6. Is there a common factor of 10, 2, and 6 that I can divide away? Yes, I can divide everything by 2. So I'm going to have negative 5 plus or minus I square root of 41 over 3. So that's my final answer, and you can see that I do have two solutions, negative 5 plus I square root of 41 over 3, and negative 5 minus I square root of 41 over 3, and both of those are complex. Both of those have a real part and an imaginary part, so they are complex numbers. And when I have complex solutions, I cannot graph those on my real axes. So you can see that I do not have any x-intercepts. Here's my parabola up here, and it never crosses the x-axis at all. So when my discriminant value is negative, my two complex solutions tells me that I have no x-intercept.